my channel. Today we are going to analyze the questions about the structure analysis, and we are going to make the analysis due to the slope deflection modified equation, because you know that it ends with the two pin. If it ends with pin, we are going to use the modified formula. Let's find it. First we are going to first I'm going to find the fixed moments. 1 second, take a pin. Take a pen, and I'm going to calculate it from the fixed amount from B to A. That will be 40 over 8 squared times 6 squared times 2 plus 2 squared times 6 over 2. It will be 52.5 kilonewton meter. Now I'm going to calculate for BC. For BC, that will be 3 times P. What is P? P 20. And times L. What is L? L is 8 over 16. And it will be 30. Yeah, it will be 30, but it will be minus 30. And now let's try to find the moments. Moment AB is equal to 0. Moment BA that will be 3 EI over the length. What is length? 8 times theta B minus delta over L. Delta over L and plus, I just confused, plus 52.5 as the moment. And now I'm going to calculate the moments BC. The moment BC will be 3 EI over 8, the length the same, and times theta B, and minus delta over L, and minus 30 as the fixed end moment. So now you can see, I told you that before, the two moments at the same support, the summation of them must be equal to 0. So let's make this for the equation. That will be moment at BA and moment BC, that will be equal to 0. And from this, I will have 3 EI theta B over 8 plus 52.5 plus 3 EI theta B over 8 minus 30 and equal to 0. From this equation, I will obtain theta B as minus 30 over EI. That's okay? Now I specified the theta B. So let's find the moments when I write the theta B in its place, and I will obtain the moment as 1 second. The moment as 41.25 kilonewton meter, and this is going to be minus 41.25 kilonewton meter. So now I have the moments, so it's time to find the shear and try to draw the shear and the moment diagrams. Let's find the shears. For the shear, I'm going to draw it here like that. Think about it as this is our A and this is our B, and I have VA and VB left here. So I'm going to write here my force, 4D, this is 6, this is 2. Total moment at A is equal to 0. I have a moment here, 41.25. At A is equal to 0. So I will take like that, 40 times 6, it will be minus, and minus 41.25, and of course for plus, one second, plus VB left times 8 equal to 0. Yeah, for now I will obtain a moment VB left. VB left will be 35.16. Yeah, so actually 56, yeah, 16, 35.16, 1 second. 35.16 kilonewton from total Fy is equal to 0. That will be 40 minus 35.16 and minus VA, and I will obtain VA as, sorry, this will move to 0, and I will obtain VA 4.84 kilonewton. And now let's do it for the second member, and it's also like that. I have a VB, I actually can write the force VB right, and that will be VC, and I have a 20 as the force here, and I have a moment also here. It's going to be in that direction. It's 41.25, and now that was this direction is positive, and for the moment at B, total moment at B is equal to 0. This direction is positive, so I am going to take like that, minus 20 times 4, yeah, and plus 41.25, and I will take as positive VC times 8 is equal to 0, and I will obtain a VC 4.84, and for VB right, that will be 15.16, because it comes from the total Fy is equal to 0, and if I have 20 minus 4.84 minus VB right equal to 0, and VB right, that will be 15.16. So let's draw the shear and the moment diagrams. If you first you draw the shear moment diagram, it will be easier for you to obtain the moment diagram. I always draw like that. If you want, you can also do it, but I think it will be better for you. At A point, at point A and point B and point C. At point A, I have a shear. You can see 4.84, 4.84, 4.84, and I will go on with the same value until the force acts, and the force will act 40, and I will come to 35, 35.16, right? 35.16, and I will go on with the same value because there is no any force, and I will come to stop here. I have a force here at B. What is at B force? 15.16, and what is the other force at B? For B left is 35.16. The summation of them, when I subtract from the 35, when I 35.16, when I subtract the summation of this VBR and VB left, I will obtain 15.2. I will obtain the 15.2, and I will go up to 15 until the 15.2. I'm sorry, I can't draw well. 15.2, and I will go on with the same, and until the force acts. The force acts here, for example, and it will act as 20 when I take the minus 20, that will come to 4.8, right? 4.8, and it's actually 4.8, and my VC is 4.84. It's 84 and 8. It comes from the calculation in the calculator, so it's okay. So I'm going to take a 4.84. Actually, this is 84. I guess this is going to be 16. Yeah, it's going to be like something like that. And it will close like this, you can see. And now we're going to draw the moment diagram. We are going to draw the moment diagram. For example, it will be like that. I will draw the beam. And this is going to be B, this is going to be A, and this is going to be C. The first area of this rectangular, you can see, I will start with here. For example, I will start with here, and I will goes up, I will goes up until the force acts. For example, the force acts here, right? I will come to here, that will be 29.1, the area of this rectangle. And I'm going to decrease because you can see, for example, this is negative, this is positive, it changes the way from the negative to positive. So let's get decrease in that amount. This is 6 meters, this is 2 meters. I'm going to 35.16 times 2 minus 29.1. So that will comes to 41.25. 41, sorry, I couldn't draw well. I'm going to delete this. For example, this will be 41.25. And now I stop here. I'm going to increase in that amount of area. So what is in that amount of area? 15.16 times 4, right? 15.16 times 4, and I will goes up in that amount, and I will come to 19.4. 19.4. For example, this is 19.4, and this is the point that the force acts. Okay, the point the force acts at 20 kilonewtons. And that will goes to 0 because we say that there is no any force. That area, if to multiply with 4, you are going to obtain this value. There will no any force. So the moment at C, that will be equal to 0 because it is spin and there is no any moment. That's okay. Thanks for watching me. The question is that I tried to do my best. If I couldn't take something really good, so please comment. I'm going to make it better.